Hello Explorers. Today we're going to be using a book or something similar to a book and our PocketLab to figure out how the axis that you rotate a book about, whether that will affect the stability of the book's rotation. We're going to be thinking about the moment of the inertia relative to each of the different axes that the book rotates about, and we're going to be using our angular velocity graph to monitor the data. For this lab you will need your PocketLab, a device to measure the data with, some tape, and either a book or something similar to the book. Here I have an empty cassette case that I can easily tape the PocketLab inside. Okay, you're going to want to start by taking the PocketLab and taping it inside the book or whatever it is that you're using for this experiment. Make sure that you align the PocketLab with the orientation that you've drawn on the front of the book. And in the lab guide, there's a diagram that will show you the orientation that you should use. So let's go ahead and get started first with our longest axis, our x-axis, and let's rotate the book about that and see how stable our rotation is. You'll want to do a few throws, all trying to get to about the same height, and throwing at about the same speed. Here's our data from our first throw about the x-axis. We see the x-axis is our longest axis, and that provides our smallest moment of inertia. So along our smallest moment of inertia, we see a very stable rotation. We see these spikes in the angular velocity of the x-axis for each throw, and then we see fairly small changes in the other axes for each throw. What this means is that the rotation has a lot of movement around the x-axis and very little movement around the y and z-axis. Okay, for this next one we're going to throw it about the z-axis. First I'm going to go ahead and record it, and then I'm going to go ahead and throw it about the z-axis a few times, putting in about the same amount of force and throwing it to about the same height as I did with the x-axis. Here's our data from our second throw about the z-axis. The z-axis is actually the smallest axis on the book, but that provides the largest moment of inertia. And we can see with this larger moment of inertia, we have a fairly stable rotation as well. We have a huge spike in each of these throws in the angular velocity along the z-axis, and we see fairly small rotations on the other two axes. A couple times we have a little bit more rotation on the x-axis, as you see in the red spike. That just means, so maybe these two throws maybe weren't as stable as the other throws, but still the rotation was fairly stable about the z-axis. So for this last one, we're going to look for a change in the y-axis, which will be the intermediate axis, and it will have an intermediate moment of inertia, so we'll see how stable that one is. Okay, we'll go ahead and record the data here so we can look at it. And as I'm rotating this, I can see visually that the book is not nearly as stable when it rotates. And I'm not trying to turn it, I'm trying to throw it as straight as I can about the y-axis, but it's just not as stable as the other ones. Here's the data from our last throw about the y-axis, which was our intermediate moment of inertia. The y-axis is seen in blue. And we can see at the intermediate moment of inertia, we have a pretty unstable rotation. And we could observe that visually as we threw the book. We saw that the book twisted about more than just the y-axis. But here we can also see that in the data. So here we have some angular velocity in the y-axis, but now, whereas in the other rotations, there was minimal movement in the other two axes, here there is quite a bit of movement along both the x and the z-axis. So we see every time we throw the book, we have rotation not just about the intermediate y-axis, but we also have rotation about the other two axes. So this tells us that our intermediate moment of inertia provides our least stable rotation. Here is one last look at all of the data together. We can see our x-axis, our smallest moment of inertia, and our z-axis, our largest moment of inertia, provide stable rotations about their axes, whereas the y-axis with its intermediate moment of inertia provides the least stable rotation.